For today's mission, I am your agent Rochelle G. Calicdan. Our mission for today is to learn about the Van de Graaff generator. To prepare you for the mission, listed below are the stations. Van de Graaff generator is an electrostatic generator which uses a moving bell to accumulate electric charge on a hollow metal globe on the top of an insulated column, creating very high electric potentials. It produces very high voltage direct current electricity at low current levels. It was invented by American physicist Robert Van de Graaff in 1929. The first machine used an ordinary tin can, a small motor, and a silk ribbon. The second patent was designed in 1931, which was assigned to MIT. In 1933, Van de Graaff built a 40-feet model at MIT's Round Hill facility, which was donated by Colonel Edward H.R. Green. The Van de Graaff can be assumed as constant current source connected in parallel with a capacitor and a very large electrical resistance. This is how the Van de Graaff generator works. A motor are required to turn the belt at constant speed around two rollers. The lower brush is attached to the voltage source which transfer a charge to the belt. The belt then carries the charge up to the second brush which will transfer the charge to the large metal sphere also known as the electrode. When the belt starts to turn around the lower roller, electrons are captured from the belt to the roller. Slowly more charges become concentrated on the roller. As a result, electrons are repelling from the tips of the brush assembly. It also starts to attract electrons from the air molecules between the lower roller and the brush. Then positive charged air will get carried on the belt away from negative charged roller. The belt therefore gets charged positively and moves towards the upper rollers. Upper roller tries to repel the positive charge on the belt. The electrons in the brush become attracted to the positive charges on the belt. The air particles break down too and the free electrons move towards the belt. The sphere takes up all the charge and the excess charge gets spread to the outside of the terminal output. The charge buildup generated in the electrode results in a potential difference between the electron and the ground. This is one of the examples of the experiment using the Van de Graaff generator by Beauty Science. Here are some of the applications of the Van de Graaff generator. Number 1 is to demonstrate practical aspects and concepts of electrostatic behavior of particles. Number 2 is to study nuclear physics and nuclear reactions. Number 3 is to copy machines for electrostatic process called serography. And number 4 is to smoke precipitators and electrostatic air cleaning. Again, I'm Rochelle. Mission completed.